Hello everybody, and welcome to example 2 on page 13 of the workbook. And this is an example of calculating a limit given a formula, so let's read this together. They would like us to estimate the limit as x approaches 0 from the right of 2 to the x minus 1 over x to the nearest 0.001. Okay, and I want to first think about this problem graphically. They give us a graph of the function over here. And so this limit is about what's happening as x gets closer to 0. So we'll start maybe by taking a point on our graph, okay, that's a little bit to the right of 0, maybe here. And which direction would we need to slide in order for x to get closer to 0? Well, x equals 0 is sitting over here, so we would need to slide to the left. And so I'm going to start at this point and slide to the left, and what does it look like the y values are approaching as we do that? Okay, well, let's slide slowly to the left towards 0. And notice that we're getting close to this point right here. What would you guess the y-coordinate of that point is? Maybe 0.6, 0.7, something like that? Okay, so whatever that is, that would be a good estimate of our limit, but then notice they would like us to estimate to the nearest 0.001. That's pretty accurate. And graphically, I don't think we can achieve that level of accuracy. So what could we do to make our estimate more accurate here? All right, well, let's think about that. One way that you can use is to make a table. We have a formula for the function that we're taking the limit of. So what we'll do is make a table that has two rows in it. One row is going to have x's and the other row is going to be values of our function. And the question then is, what kind of x values do we want to substitute in here? Well, our limit kind of tells us we want x to approach 0, so we're going to pick a value that's a little bit bigger than 0, like maybe 0.1. Okay, it wouldn't have to be, but that's a possibility. Can you think of a number that's even closer to 0 than 0.1? Okay, how about 0.01? Okay, even closer than that would be 0.001, and so on. So the idea is we want to choose a list of x values that gets close to 0. That's the key to figuring out what's going on with this limit. And what we're going to do now is just take these numbers one by one and substitute into our function. So we could start with 0.1. Okay, and I'm going to go down here and just substitute 0.1 in for x. Okay, you can do this on your calculator and confirm that what you get if you round off to 3 decimal places is 0.718. Okay, then move on to the next value, 0.001, and same thing. We're going to plug 0.001 in, or I'm sorry, just 0.01. Okay, you can do that calculation and confirm that you get 0.696. Okay, and the other two calculations would be the same. I'm going to just show you what they wind up being. Rounded to 3 decimal places, you actually wind up getting 0.693 for both of these. Okay, so how do we read this table then? Well, the question you want to ask yourself is, what do these numbers approach? Okay, 0.718, 0.696, 0.693, 0.693. If we kept going and rounding off to 3 decimal places, the fact that these two numbers repeated tell us that we're probably going to keep getting 0.693 over and over again, and so therefore that would be our best estimate of what this limit is. Okay, so the limit as x goes to 0 from the right of our function is approximately 0.693. Okay, and there's our answer.